Hi, everyone. Welcome to Use C# with Godot to make games. I'm Michael Hawker, and this is a follow-up from the student conference session, Games in Godot. Let's make a classic paddle game with C#. So if you want to follow along with our starting point from that code, you can find that at aka.ms/netconf23/student repo. But don't worry, I will get us all up to speed on what we did there and what we're going to be doing today. So who am I? I am an engineer by day, and by night, I am a game designer and developer. I did my master's thesis on MMORPGs. I've participated in a few Ludum Dare events. I've developed my own programming game. I've even kickstarted a board game, so it's a passion of mine. And earlier this spring, I started working with Godot and playing around with it and C# and what's possible there. So I wanted to kind of share some of my learnings here with you today. So, quick overview of what we're going to be covering. We're going to quickly talk about what Godot is and some terminology there. If you're not familiar with Godot or coming from Unity, I'm going to discuss the .NET New template that I used to get our project started in the last session, and what we have so far with our project and where we're going. And the rest is going to be coding. So, what is Godot? Godot is a free cross-platform open source game engine. It's built for making 2D or 3D games or combinations thereof. As we know, there's a lot of blending between the two these days. It supports programming with their built-in GD script, C++, and of course C#. That's why we are here today. And there's other languages that are supported through community add-ons as well. And if you've played any of these games lately, such as Brotato, Cassette Beasts, or Dome Keeper, they were actually made with Godot, so you might already be familiar with what the engine is capable of. And a little tidbit of information, it was named after the play Waiting for Godot. So if you've come from Unity or not familiar with Godot terminology, wanted to kind of cover that quickly here as an introduction. In Unity and in Godot, you have scenes, which represent your kind of view into one of your levels or your menus or whatever they might be for what's displayed on the screen from the engine. And in Unity, you would use a prefab that you would instantiate something within that scene that you might want to use multiple times, be that like an enemy, for instance. And in Godot, that concept is also a scene. So scenes are really that collection that represents either your main visual and viewport into your game's world, or something that you want to create within the world itself. And usually those in Unity are game objects. In Godot, those are called nodes. And where in Unity, game objects are made of multiple different components, Godot has nodes for that as well. And so you end up with this hierarchy of nodes within Godot that represents your game object, so to speak, from that standpoint. And so you might have a player that's used physics object that has another node within it that's the visual, and then a node that represents its boundaries within the physics engine. Maybe it plays a sound when it enters the scene, and so you have an audio stream, and maybe it's followed by the camera. So you end up with these hierarchies of your nodes that represent your game world. And the nice thing with Godot is you can just package those up in a scene if you suddenly need to instantiate multiple enemies. So it really gives you a lot of flexibility with how you organize your structure of your game. So in the previous talk, which I'll show the link to here in a second, I used this template that I created, which is for .NET New. It's just basically a simple blank template, but has all the configuration preset for connecting to VS Code or Visual Studio for debugging. And so in the previous session, I kind of covered all about getting started with that from ground zero and getting started. So I assume you've kind of gone through that process already here and a little bit more familiar with the Godot engine and C#, but you hopefully make sure to be able to follow along here today as well. And so we can install that through the .NET New system on NuGet, or you can find the repository at github.com/mikeware/godotnet.blanktemplate. And so here's what we have so far. We created a paddle game with a couple paddles and a ball. You can find the link to the slides and the link to the recording of the previous session, as well as the code we're going to use to get started here today at aka.ms/netconf23/student repo. And so let's go gadget Godot, get started with the engine. You can find it at godotengine.org, and we will show you what we've got so far and where we're going to go. today. So quick note for downloading the engine. You want to make sure you download this .NET version here. That's going to give you the C# support. Of course, that's what we want to be doing today. And here's the student repo you can see in the 2023 gaming track Godot. This is the source code, has the slides, and we'll have the link to the previous talk that has all the setup for everything that we've done to get to our paddle game so far. That was started from that template from ground zero in the previous talk. So if we go into the Godot editor, you'll see here we have our main scene, and this is from the file system down here. And this scene that's displayed here in the scene tab is made of our ball, which has our visual and collision shape and has a script attached. And then it has a couple of paddles left and right, which are each actually scenes, which we can see from this icon that are from down here. And they also have scripts attached because the scene, we attached a script to that scene as well. And then we have the top and bottom wall. So the main goal with this paddle project was to use the physics engine to do a lot of the heavy lifting for us, rather than for us to have to worry about a bunch of math, leverage the built-in physics engine in Godot to do that. And so that's why we created these barriers at the top and the bottom of our level, is to represent the ball being able to bounce off of the top and bottom of the screen. So I think that's the brief kind of overview here of what we are starting with. So let me run this project and we can see it get going here. And of course, the ball is going at an unoptimal angle for quickly demonstrating the project here. But maybe it's something we'd want to adjust and not use a completely random angle, but a one that's more towards the paddles here. But we can see a problem, and this is kind of where we left off the last talk, is that the ball hit the paddle and the paddle started moving in a random direction. So that's clearly not what we want to have happen here. And so we're going to go into our paddle code. And this was one we used with the character body 2D, which represents a physics object that is manipulated by a script. We're manipulating it by moving it up and down with input. And we used basically most of the default template, though modified it to work with our paddle. And we use this built-in move and slide method, which is provided by Godot and does a lot of the kind of magic of the physics engine, kind of more geared towards a platformer, where you're going to have a character that might jump into a wall and you want that character to kind of slide down the wall. But with a paddle here and the ball, that's not really what we want to be doing. We want to have a little bit more control over our collisions. So we're going to use this move and collide method, which takes how much we want to move. So we're going to use our velocity and time here as an input, and it's going to return if we have a collision. And so we're going to check if we have a collision and then get what we collided with. And we're going to see if it's a ball. And one of the cool things here, you can see this is actually a C# type. And so if we look at the C# class here, we have our ball, which inherits from another type of physics object, a rigid body, which is manipulated by the physics engine. And it's a partial class. So Godot uses source generators, which helps tie in our C# code and our class here to the game objects and nodes within the editors themselves. So this script is attached to this ball here, which we can see here. If we hover over that, it's the ball.c# class. And so when the engine is instantiating this node and this game object within our scene, it's actually using the same instance of our class here that we've constructed in C#. And so that really makes this powerful, is that we can use the built-in C# typing system on any of our nodes to detect and see if that's what we're looking for. So, if we have some base class of an enemy in C#, we can now use that to check if whatever, is getting collided with is an enemy. And then from there, we're just manipulating the ball's velocity and using the bounce method on the normal of the collision to make sure that the ball bounces. Like anything within development, there's a few different ways to do things, and maybe it would make sense to have the ball do more of its own collision detection over the paddle. But as we were just kind of getting started and using the built-in code templates provided and using the physics engine to kind of simplify this process, just to show showcase things. This kind of is just where we've ended up for now. So maybe it's a sign we want to do some refactoring later. But if we hit F5, we can run the project again. And so now we can see the ball bounces. And if I try and hit it on the side of the paddle doesn't move, but the ball goes off the side. And this is what leads us into the rest of what we want to do today. The ball went off the side. One of the players should score. We want a way to display that score. And we want the ball to reset back in the middle so we can kind of do the next volley and round of the game. So we want to go back to our Godot scene here. And I'm going to right click on our scene root and add a child node. And I'm going to use the canvas layer here, which is a node for rendering objects within a 2D scene. And Godot has a kind of rich UI layer and ways to different UI containers that let you make responsive UI elements. That could be a whole talk in of itself, not something I'm going to cover today. So we're just going to quickly add a label of a control node here directly and drag it around and manipulate it, not really worry about making it respond to different size screen resolutions and those sorts of things. But yeah, I can enter 0 in here, and down in the control properties and the theme overrides, I can change its font size and make this larger so we can see it here, and just drag it into our scene for easy display for today. And maybe I want to label this player 1 score, and I'll call our canvas layer our display. And then I can right click and duplicate this node and call this player 2 score, and then be able to move that. I can use the shift key to keep it on the same Y axis here. And now we have our display of our 2 scores within our scene. And generally we want to have different classes and responsibilities between objects within our game. Like the display might be responsible for just updating these text boxes on these labels, where the ball has its own logic, and just like our paddle has its own logic. And this might be across different scenes within our game as well. And so we're going to, just kind of keep things within one scene here for now, but we're going to add another script to our display to kind of represent this hierarchy for us today. So I can use the add script button up here, and I want to make sure to change the language in this drop down to C#, and we can see it uses the name of the node as our class name. And so now we have a C# class. I can give this a namespace if I want. I can use my Godot paddle.game. Godot doesn't really care about namespaces in C#, so this is purely for your own organization within your classes, and services, or any models or whatever else you want to do within C#. You can give them different namespaces if you desire, but it's not a requirement. And we're not going to do anything processing here today, so I'm just going to get rid of that. And what we really want to do is have references to our labels. So I'm going to create a player 1 score property here. And we're going to copy this and create one for player 2 score. And so we want to be able to reference these labels from within our code from these nodes within the editor. And so one common way that I see a lot of folks doing is you can right click here and go copy node path. And in your ready method, you could say my player 1 score property is going to get the node that's a type of a label that's at that path. So get node is a method on any of our nodes. But there's a few things here, right? Like we have this hard-coded string, which is supposed to represent a path within our scene. And so if we wanted to move this node around within our scene, then the path would change there. And also our script is not on the root of the scene anymore, right? We added a script, our C# class rather, to this display node that's somewhere within our scene. And so now we have to worry about whether we need an absolute or a relative path here. So that's a bit messy, but there's an easier way, and we don't even need the ready method at all. We can basically just go to our property here and add this export attribute. And so I'm going to hit Control-Shift-B to build, and basically let the source generators that look for this export attribute do some magic for us. And what the export on our properties, or you can use these on fields as well, tells the editor that on our display class, you can see we're an instance of our display class, which inherits from canvas layer. We actually have our player 1 and player 2 score properties here that we created. So that's kind of the magic of the export attribute, is now we can go into the editor in our scene and assign to these labels that we want. You can see I can't even click on other types of nodes because they're not labels, because I typed that as a label. And so I can select our player 2 score, and I can save this scene now. And one of the nice things about this is not only does it keep our code a little bit simpler here, that we just have a property, but now if we move that node around, or if we want to reuse this class in other ways, the selection and connection of the scene and that visual to our code is now done through the editor, and it is now kind of not reliant on that magic string. And it makes it very easy for us to reuse this in different ways and just not have to worry about the structure of our scene and how that's tied to our code directly. Great. So now we need a way to communicate between the ball that knows where it is and where it's going on the screen to this display, and updating these labels so that we can show the score in the game. And so Godot has these things called signals, which are basically events for communicating between objects. But that system kind of still relies that you have a reference or a structure and kind of know the structure of where these objects are within the scene. And maybe, you want to have different scenes or have very different systems within your game engine. And it's going to be harder to know that structure of where things might be and how you might want to communicate them. So we really want kind of a more generalized publish and subscribe system. And we're using C#. So we can actually just go over to NuGet and use any C# library that we want effectively. And the best messenger class I know that's the fastest and doesn't have any memory overhead is the MVVM Toolkit's messenger class. So I'm just going to include a reference to the community toolkit.mvvm package. So I'm going to go to my terminal. I'm going to use the .NET add package community toolkit.mvvm. That's going to, if I look in my C# project, add a reference here to that package and the latest version. And so now we can use this code within our ball to notify when the ball leaves the screen. So I'm going to override the physics process method. This gets called by a fixed rate by the physics engine in Godot. And I'm just going to check if our position of our ball is less than 0. So that's going to mean that player 2 has scored. So if our player 2 is on the right, and if the ball goes off the screen on the left, then they've scored. And then otherwise, if our position is greater than the viewport rect, so this represents the size of our screen, then our player 1 has scored. And so when this happens, we want to reset the ball, right? We want to put the ball back into the middle of the screen. So we're going to take our code here and make a reset ball method. And so this is going to apply that impulse of a random direction. And we also want to set the position to the middle. So we're going to set the global position here, and we're going to use that viewport rect size and divide it by 2. So we can just use the built-in vector math helpers here to divide that rectangle by 2 and get the midpoint assigned to the position, assigned to that random direction. And we want to make sure we do that when the ball comes into the scene as well. So great. So now we have our ball reset. And next thing, we want to send that message to say that the player has scored. So we're going to use the default messenger, and we want to use a send, but we need to type to send a message. So I'm going to add a messages class. Just call it messages.cs, or file rather. I could use the same namespace if I want. So godotpaddle.game. And I'm just going to use a record class for this. It's nice and easy, lightweight. I can call this player scored message, and I can give it an attribute for the player. And so, I could create separate messages for each player if I wanted. I'm just going to create one for simplicity here, but it gives you a lot of flexibility in what types of messages you can send. And now I can just use that player scored message and new that up with the number of the player that scored. And I can copy that and set that to player 1. So now we're sending out the message. And so if we go to our display now, we can add a interface from the MVVM Toolkit as well called iRecipient and player scored message. And we can just use the light bulb to implement this interface. So this interface gives us a method and says that we are capable of receiving the player scored message. Of course, when that happens, we're going to use message.player. If that equals 1, then we will do player1 score.text equals, and we actually probably want an integer that keeps track of that score. So we can create that here in a second once we've copied this for the second player. And so now we can use the light bulb again to generate these fields. VS Code is smart enough here for us to know it's integer. So great, we have an integer, keeps track of the score. We increment it when we get the scoring message, and we set the text label node within Godot to display that value. But the last thing here is while the interface declares that we're capable of receiving this message, it doesn't actually listen for the message. We need to tell the strong reference messenger that we actually want to listen to those messages. So we're going to override another method here called enterTree, and we're going to tell the strong reference messenger that we want to register to listen to all the types that this class supports. So the register all is just going to look for these types of interfaces and be able to pass those messages along. And we will override the exit tree as well to unregister when the node leaves the scene. We could register all the different types individually. That's a little bit more efficient, but we're not going to be registering, unregistering that often. And it's easy now for us to come over to the class and add another interface for another type of message if we care about different things here. And the nice advantage of Godot having these nice enter and exit tree lifecycle messages and events for the node coming in and out of the scene is that it allows us to really easily use the strong reference messenger here and just register and unregister all. If we didn't know when the node was leaving, we could use the weak reference messenger as well. But the strong reference messenger gives us a little bit of a slight performance boost there comparatively. So great. Now we should be registering to the messages. We're sending the message from the ball. We are updating the score. We should be good to go. So I'm just going to hit F5 and we'll cross our fingers here. And hopefully our game is going to be updating. Yep, the ball went off the screen and the player scored. And we can see both scores are working now. We also noticed that the ball was speeding up. And if we think about it, we are applying an impulse to the ball that was already moving, and we never reset its velocity. So in some instances, we're adding to the existing velocity. So there's a lot more we can explore and continue with this project, but we're out of time for today. So I hope this was useful, kind of showed you a little bit more of what you can do with C# and Godot. And I appreciate the time you've given us today. And if you're looking for those resources, you can find them here, Godot itself, the template that we used to start the project initially in the previous talk, and the link to the previous talk and its code that we used here today to get started with all these other features on this project is at aka.ms/netconf23/student repo. Thanks again, and it's a pleasure joining you today.